Hi, I'm Tian, and this is my Capstone project about the modeling air quality in the mainland China. So the air pollution is a mixture of solid particles and gas in the air, including the carbon emissions, chemical from the factories, dust. And the air pollution is gradually become a serious environmental problems in the world, especially in the developing countries. Um, the economic cost of the air pollution is huge. According to research, in China, the government will pay almost $900 billion a year for the treatment to the air pollutions, and for the U.S., the number is $600 billion. In the 2018, the cost of the dirty airs equate to the 6.6% of the Chinese GDP, is 5.4% of the India's GDP, and 3% of the US GDP. So my goals of the project is to creating the models to predict the air qualities and find the most important variables to the air qualities. So first things I do is the data collection and processing. So our data is from the National Statistics of China. I will use air quality index is a numerical unit to show the degree of the air pollutions. So the data set includes the 2000 to 2015 US air quality index data and the 18 variables from the 11 provinces with bad air qualities. The dataset has 18 variables. Most of variables are from the energy consumption, like coal, electricity. Some of variables is about the economic, like the GDP. So for the next step analysis, the first thing I do is to create the correlation matrix. We can say there exists mapping positive relationship between the variables in my data sets. It may bring a problem like there may exist some variables useless to the data sets because they have a strong relationship between the variables. So some variables can represent by the other variables, which is more important. So for solve these problems, the first thing I do is do the feature selections. Why we need a feature selection? Because I mentioned before, not all variables make sense for the models. So by making a feature selection for the variables, we can remove the redundant features from the data sets. Actually, on this part, we can also use PCAs to solve this problem, but the PCAs will combine the features to the new components. It's hard to explain the relationship between the features and the AQI data. So I use the feature selection, not the PCA on this part. The results of the feature selections is here. 14 attributes can pass the test, and one attributes can confirm it's unimportant. It's a coal consumptions. I remove it for the next steps. So after I move the useless variables, I'll do the random forest and support vector machine to do the classification to the data sets. So first, I need to convert to the air quality index from the numeric to the classifications, use the tables. Like if the air quality index data is between the 51 to 100, it will convert to the moderate. If it is between the 101 to 115, it will convert to the unhealthy. So this is a briefly introduction about the random forest. The random forest consists of the multiple random decision trees. The trees of the random seeds are built into the trees. First, each tree built on the random sample from the origin data. Second, and each tree node, a subset of features are randomly selected to generate the best split. The random forest is very good on the interpretabilities, and it has the most important feature of the random forest is we can use a random forest to create the to find the importance of the variables. So this is results of my random forest models and SVM models. We can see for the random forest is perform very good on the first 2 degrees. It has 100% accuracies, but it's perform not good on the 3rd and 4th degrees of the air pollutions. And for the SVM, it perform not good like the random forest on the first 2 degrees, but it's perform good on the when the AQ data is higher than 151. So this is a variable importance created by the random forest. We can see the most important is this one, the government investment of the waste gas treatment. So this is makes sense because before the 2008, the air quality is very bad in Beijing, but for the Olympics, the Beijing government spent a lot of money to solve this problem. So the air quality become better in Beijing. And the second is the number of cars, because it's related to the car emissions. Is BC as one of the most important features to the air bad air qualities. And we can also use a regression to predict the exact number of the air qualities. Here's the results. This is the tables include the prediction and the observations of my of my regression models, and this is MSE of my models. Most of the errors is less than 20. It means it performed not bad in my data sets, but it has similar problems like the classification. It performed not good when the AQ data is higher. Like we can see this one, the true value is 135, but the prediction is 107. It has a 30 difference. It's huge. So the both classification and regression models perform good on the first 2 degrees, but perform bad on the higher degrees. I think the reasons is although the economic level and energy consumption is so important for the air pollution, but there still exist some other variables may related to the air quantities, like the wind speed. So it means the air pollutants maybe not created by the poisons. It may carry by the wind from the other poisons. And the second possible reason, I think, is there has not too much samples in the extremely case more than 151. So that may be the reasons for why the model is performing bad on the extreme cases. And there is news main link to my project is because of the coronavirus. The Chinese government shut down all activities in the Hubei, so which results certain decreasing in the air pollution in the Hubei. This is photos. we can see on the March, the air quality has become much better than the January's because of the government shut down all the activities. Yeah. Any question?
Thank you. Thanks.